Okay, he's good. All right. So let's say that we want to take the fifth root of 32. Okay, you're not sure what it is. The answer is going to actually be 2. So if you're able to get 2 on your calculator, fantastic. Here's what you're going to do to get it. You're going to put in the radicand first. So you're going to put in 32 first. Then you're going to find either this button or this button. Depends on which one you have on your calculator. Normally you have to hit second to find it. Normally it's like hidden in yellow or hidden somewhere. Then you're going to put the index. Okay, so I had told you to put index then radicand, which Leah's, that's what you're going to do because that's what I have to do on my big fancy calculator. But if you have the smaller ones, this is normally what you have. And then you should end up with 2. Did everybody get 2 on theirs? Is everybody okay? Like a nice even 2? If you didn't, let me know. Okay, did you get it? Okay. So you're going to do 32. Good. And then your button. Yes, it is, but you're going to hit second back first. Good. Oh, you know what? Yours is the opposite. Huh. Yep. So then poor Elazar does have the opposite. His is going to be, for him, index, and then his actually looks like this, and then he's going to hit 32. Okay, so you may have it the other way. That's why I want you to play now, so you know how to get it. Okay, so you, ma'am, put it over here. Okay, you're going to do index first. So you're going to do 5 first, because it's the 5th root. And then you're going to go math. And right down here to this guy. Okay, good. And then put in 32. That's your, and there you go. Okay, so math will be your pick. Did you get it, Rian? Yes. Okay. Did you get it, Sean? Okay. Are you okay? Did you get it? Okay. All right, both of you ladies got it. You figured it out. Okay. Now you're good to go. You have the big boy. Okay, so you have one at home. You figured it out. Okay. All right, good. I just wanted to go over that with you because, you know, you're my little quiet class, and I taught it to you first, and I told you the wrong way, except for, you know, a couple of calculators. And then yesterday I was telling Tuesday, Thursday class, and you guys are quiet. You just all just kind of sit there and stare at me. And Tuesday, Thursday, they're like, you know, they're like the question kings and queens, and we're talking and discussing and answers. And it's like the opposite of you guys. And they're all like, that doesn't work. Mine doesn't work. That doesn't work. So we had to stop class and figure out how to make it work. And so I thought, well, gosh, I better tell you guys because y'all are just sitting there, you know, not knowing how to do it. So anyway, as long as everybody can get that, that's huge. That's huge. So when I tell you to do a root in your calculator, so for example, if I tell you to take the 4th root of, try this one. I think you can take the 4th root of 4,096. Try taking the 4th root of that. So 8, is it 8? Okay, I knew it was something. Everybody get 8? Depending on what you had to do, the 4th root, whichever way you had to put it in first. Everybody good? Got it? Okay, Leah, did you get yours? Okay, all right, so that's great. That means we don't need the radical anymore, right? We don't need it because it came out perfectly. What if I told you to take the cubed root of 25? If you go to take the cubed root of 25, do you get a whole number? You don't, you get a decimal. That's when you can't trust your calculator anymore. You have to put your calculator down, it's of no use, and factor tree and try to reduce it the best you can. So if you get a whole number, fantastic, radical's gone, you're good to go, you move on. If you get a decimal, because this is not perfect, okay, then you can't use your calculator. That's when you'll have to do your factor tree and try to reduce and try, I mean, there's nothing you could reduce for him, he's done, but does that make sense? Because we also had the conversation in Tuesday, Thursday, yesterday about how do you know when to leave the radical and how do you know when to get rid of it? because some students were just leaving the radical in their answer the whole way, even though they didn't need it. So, you know, when you guys come up with these questions, ask, because I feel so bad. I feel like Tuesday, Thursday's at an advantage because I've got students asking all these questions that I know everyone's thinking, but in here, no one's saying anything. So if you have a problem, I promise you other students do too. So, you know, make sure that you ask. Okay, let's jump in then. Everybody okay with calculator then? Okay, that's going to come in handy. So we are on page 6. We just have 4 more on page 6. And this finishes homework 2. So I think we're down here at the bottom of page 6. And we'll jump right in and finish this. Okay, so we have this guy. This is so ugly. Maybe I can make him bigger, possibly. No, then he gets super blurry. That might be the best I can do. Okay, gosh, he's blurry. Okay, so here we go. I see I have a top and a bottom, right? So I'm gonna just do the best I can. First thing I'm gonna do is distribute this little exponent to both items inside. So don't forget that 3 in here has an exponent of 1. So my numerator is gonna be 3 cubed, right? I just distribute it. And then 1/4 times 3 is 3/4. You're just multiplying your numerators, okay? It's like having 1/4 times 3 over 1. All right, my denominator stays. He's just fine because there's no one to distribute and he's not negative. If this were negative 1/12, what would we do with him? Move him up, right? We would stick him up in the top. Okay, good. All right, what's 3 cubed? We can do that. So remember, you can always do that in your calculator if you're not sure. He's a nice little 27. So we cleaned him up. Okay, I'm just gonna write everything over so we have lots of steps. Try not to forget any steps on you. Okay, now I have an x over an x. So what am I gonna do with those exponents? Subtract, right? If they're sitting right next to each other on the top or the bottom, I add them. But since we have 1 over the top, I have to subtract. Now our rule has always been biggest minus smallest, and our answer is gonna live where the bigger one was. That's still the rule, except that a lot of students struggle with figuring out which fraction is bigger. So if you're comfortable and you know 3/4 is bigger than 1/12, do 3/4 minus 1/12. If you're not sure which one is bigger, then you can always do top minus the bottom. That's your go-to thing. If you're not sure which fraction is bigger, just do top minus bottom. If it comes out positive, you leave it in the top. If it comes out negative, where are you gonna put it? The bottom, okay? All right, so I would like to do 3/4 minus 1/12. Well, you know I can't do that because I have to have the same denominator. So my LCD would be a nice 12, right? So I'm gonna multiply this guy, top and bottom, by 3 and get 9/12 minus 1/12 is a nice little 8/12, okay? I can reduce 8/12 if I divide top and bottom by 2, well, by 4 actually. That reduces nicely to 2/3. Okay, so I'm going to come back over to my answer. I have a 27. I subtracted these, so I no longer have anyone on the bottom. They were subtracted, and I'm left with x to the 2/3. And there we go. Okay, does that make sense? How to do that? Remember those exponent rules? No matter how ugly math problems get, take it back to the rules. What do? You subtract the exponents. Well, they're fractions. That's okay. Then they're going to need a common denominator, right? Okay, I have an answer. Great. Is it a negative exponent? Move it across a fraction bar. So just kind of go through your mind with all these little math rules, all right? So that's kind of the basic gist of this section, is just dealing with these fractional exponents. Remember, this is all that it wants. How do I know it wants it left in this form? Because the problem had fractions as the exponents. So it wants the answer to have fractions as exponents. Now, what if it told you to put your answer in radical notation? What if that was the directions? If it said to put that in radical notation, then 27 does not have a fractional exponent, so he stays. The fractional exponent is on x. So let's see if we can remember how to put him in radical notation. His exponent is 2. That's his numerator. What am I going to do with the 3 on the bottom? Perfect. That is your index. That would be 27x to the 2/3 written in radical notation. Okay? Now, it didn't ask for that, so my math lab would count it wrong if you did that. But that would be it. So just remember that. Okay? Top is the exponent, bottom is the index. 27 doesn't do anything because it just has an exponent of 1. Okay, so again, why are we doing this? Why on earth are we putting fractions in exponents, right? Like that's your own special kind of hell, right? Well, because there's certain limitations with radicals that you just can't do. You can't combine radicals unless things are perfect. So for example, look at these two. I have the 4th root of y and the 5th root of y cubed, and it wants me to multiply them together. Well, guess what? I can't, because you can only, I really should say multiply here rather than combine. Multiply or divide. Okay. You can only multiply and divide radicals with the same index. That's the super secret situation there. So I can't do anything with these. They don't have the same index. I have a 4 and I have a 5. So how am I going to make them combine? Because I have to make them combine. Change them to rational exponents. Because if we change them into fractions, then look what we can do. We can make any two fractions combine. We can find an LCD. And then if we have an LCD, we can combine them. So that's why we're doing fractional exponents, okay? So I'm stuck if I leave it in radical form. But since they're different, I'm going to change them to exponents, combine them, but I have to make sure I put them back in radical form at the end, because remember, whatever form you start in, you have to end in that form. You can do anything you want in the middle. Okay, so here we go. I'm going to change them. So this guy, y to the 4th root of y is going to end up being y. His exponent is a 1. His index is a 4. So it's y to the 1/4. I'm going to multiply that by this guy. His exponent is a 3. His index is a 5. Okay, so we just wrote them over. We can multiply. All right, what happens if we want to multiply things together? What do we do with those exponents? Anybody remember what you do with the exponents? We add them. Good, we have to add them. Okay, so I'm going to come over here. I'm going to take 1/4 plus 3/5. That's my goal now. So I need an LCD. For 4 and 5, that's going to be 20. All right. So I'm going to multiply 1/4, the top and the bottom, by 5. For 3/5, I'm going to multiply the top and the bottom by 4. Okay. I get 5/20 plus 12/20. That's going to give me 17/20. So my answer is going to be y to the 17/20, because that's what I actually added together. Now, I can't leave it like that because I have to have it in the form where I started. I started in radical form, so I need to change this guy to radical form. So what does this mean as radical form? It means I have y with an exponent of 17, right? Because that's my numerator, and it's the 20th root. And then you just check it, make sure you can't reduce it. There's nothing I can do. My exponent is smaller than my index. You're done, okay? And there's your answer. So it's a lot of that kind of stuff. Let's try it again down here with b's. Okay. All right, so we have the 5th root of b to the 4th, and then we have the 7th root of b. Good gracious, right? All right, so we can't divide these because we have 2 different indices. We have an index of 5 and an index of 7, right? Okay, so we're going to change these. Let's change them to rational exponents. So in the numerator, I'm going to have b, his exponent's 4, his index is 5. In the denominator, I'm going to have b, his exponent is 1, his index is 7. So that's what the problem actually looks like with fractional exponents. Is everybody starting to feel more comfortable with how to put that into rational exponents versus radical form? Okay, so if you have one exponent over the other, what are you going to do to them? Subtract. Good. So if you know which exponent is bigger, which fraction is bigger, then you can do that one minus the other one. Anybody comfortable knowing which one's bigger? 4/5 is actually bigger than 1/7. You can always put that in your calculator. It'll give you a nice little decimal and you can compare them so you know. But otherwise, remember, we're just going to go straight to the top minus bottom situation if you're not ever sure. Okay, so I'm going to come over here and I'm going to do 4/5 minus 1/7. Well, I got to have a common denominator. So for 5 and 7, I'm looking at 35, right? So for 4/5 to get a 35, I'm going to multiply top and bottom by 7. For 1/7, to turn into a 35, I need to multiply top and bottom by 5. It gives me 5/35. Now, if I subtract 28/35 minus 5/35, I get 23/35. I can't reduce that. It is what it is. So I come over here and I put it on a B and I'm done. It's positive, so I'm done. If this had come out to be a negative 23/35, then I would have had to do 1 over B to the 23rd 35th because I would have had to move it below a fraction line. Okay. All right, everybody okay with that? Seeing those? All right, I know it's one of those things you really have to keep up with your homework, so you practice, you know? Okay, this is my math lab question. True or false? 9 to the negative 1/2 is a positive number. That's tricky because students see that negative and they want to say, no, that's a negative number. But is the number negative? No, his exponent's negative. So what does this actually mean, 9 to the negative 1/2? It means what I really have is 1 over 9 to the positive 1/2, right? All you do is move it under a fraction bar. And what we know, I mean, you can leave it just like that if you want. It's obviously true. It is a positive number. But if you wanted to keep going, okay, what does this mean as far as radicals go? It means it's 9 to an exponent of 1 with a square root on it, which we also know is equal to 1/3. 1/3 is definitely a positive number. So they try to trick you with that. When it asks you if it's a positive number, all you're doing is looking at the number, not the exponent. Okay? Is everybody okay with that? All right, so here's what we do. Section 7.3, that's homework 3, is this one page. And it's all about just simplifying radicals, okay? Then homework 4, which we're gonna hopefully start today, we are actually gonna add them, subtract them, and multiply them. We don't really divide. We'll talk, it's more of a simplification situation, but we'll talk more about that later. Okay, so simplifying radicals, here we go. All right, so why are we back to radicals? Why did we do this fractional exponents right in the middle of a whole radical chapter? Because remember, we can't combine, and by that I mean multiplication and division, radicals, unless they have the same index. So if they do, that's fantastic. but eventually you're going to get to a point where they don't. And when they don't have the same index, change them to your rational exponents. Okay. All right. So if each index is the same, you're going to multiply or divide the radicands, the stuff inside, just as you need them. Okay. And then leave your index alone. You leave your index alone. If it's a different index, write them as exponents and combine. So here we go. These are both square roots. Fantastic. I can multiply these. Your answer is going to be a square root. Your index does not multiply. It does not add. It does not change. Okay. You have same thing. So index does not change. Put that somewhere. Index stays the same. All right. All you're going to do is handle the radicand. So 6 times 5, we're looking at a 30. Okay. You can put the square root of 30 in your calculator. You're going to get a decimal. So it's obviously not perfect. Boy, I don't know about you, but it really seems like I ought to be able to do something with the square root of 30. So if you're not sure, you can always make a factor tree. You can put a 3 and a 10 or a 5 and a 6, whatever you want to do. Break them down till you get a bottom branch of prime numbers that multiply to give you 30. But look, I'm looking for groups of 2 of the same numbers. Do I have any at all? No. So as much as I feel like I ought to do something with him, I can't. He's already simplified. Okay. All right, let's look at this guy. Each index is the same. We're good to go. Our answer is going to be a cubed root. Okay. Multiply what's inside. 2 times 5, we got a 10. Can't take the cubed root of 10, can't reduce it, you're done. How do I know I can't reduce it? You can do a factor tree. You're not going to have multiple numbers that are the same. All right, let's look at this guy. Both of them have an index that's the same. Perfect. It's a square root. Answer is going to be a square root. You're just going to multiply stuff together. Students get a little concerned here because one has an x and one doesn't. But what if you had, 3 times 5x just out in the algebra world, or multiplied together? You guys wouldn't hesitate to tell me that's 15x, right? Same thing when it's under a radical. It's just 15x. You can't reduce him, so you're good. All right. Everybody kind of good on that multiplication stuff? It's not that bad. It looks hard, but it's not. All right, let's talk about division. So if you are comfortable taking your roots of a fraction, go for it. If it bothers you and you want to put that radical in the top and then a separate radical in the bottom, you can do that. I can change this to look like this. It's the same thing. You don't have to have that step, but you can certainly use it. All right, is there anything I can do with the square root of 6? No, he's just done. What's the square root of 25? 5. You're done. Okay, so just nice little reducing of things. All right, now down here, I know that 4 is just like hanging out in no man's land. That's supposed to be the index. The computer gets weird. Okay, so if we want to, we can separate it and do a 4th root of x cubed in the top and a 4th root of 16 in the bottom. All right, now if I go to the top, there's not anything I can do because remember that little rule. If your exponent is smaller than your index, you're done. So there's nothing I can do with him. Is there any way to reduce this 16 down here? Is there a 4th root of 16? There is. Good. And it's 2. You can put that right in your calculator with those skills we just learned. Depending on which calculator you have, put that 4th root in there and try it. Make sure you get a 2. Otherwise, you can take 16 and break them down, and you're going to find 4 2's. And then that's going to let you know it's 2. All right, we got another one. It's a square root this time. I'm going to break it apart. I just like it better. For some reason, it makes me think it's easier. Okay, here we go. So we got to test our skills a little bit. So in this top, I can reduce this. So remember, for your letters, exponent divided by index. So for my x, I have a 2. Remember, this is an index of 2. 2 divided by 2 gives me 1. So x to the 1 comes out. There's nothing left over. So am I going to have any x's under my radical? No. Then I see the y. Is there anything I can do with him? No, because his exponent is smaller than the index. So I am going to have to create a square root and put him in it. So this is the kind of problem that Tuesday, Thursday was struggling with a little bit because they don't understand when to use a radical and when not to use a radical. So remember, if you end up with something that's perfect, a whole number, and it comes out, you don't need the radical. Anything left over goes under the radical, okay? All right, here we go. Square root of 256. I have no idea if he's a square root. Put him in your calculator and see. If he comes out to be a whole number, which he does, oh, 16, sorry. I didn't think that sounded right, but with your mask, it's just hard. So it ends up being 16. Now, if you had, Jemai, are you okay, sweetheart? You do? Do you want to go sit out there where it's quiet? You don't have to hear my voice. If you're not feeling well, I've got a video. I can send you the video. Are you sure? Put your little head down if you need to. All right. Okay. Y'all, back row, watch Jemiah for me. You're on high alert. Okay. All right. So the square root of 256 is a whole number. Okay. So we know that it's going to be fine. You can always break it down. All right. What about z squared? What's the square root of z squared? Just going to be z, right? Because I do 2 divided by 2, the exponent divided by the index, and then I don't have anyone left over, and I'm done. Okay. All right, let's look at this guy. We have a cubed root here. Okay, this one's going to get a little messy for us. So if I put the cubed root of 24 in my calculator, do I get a nice, neat whole number? Nope. That's the point where you have to say, okay, I'm putting the calculator down. I got a factor tree, right? So you can choose 3 and 8. You can choose 6 and 4, whatever you want to do. 12 and 2. Okay. No matter which one you choose. Oh, sorry, I'm getting too low. See, I'm writing off the page. You guys don't even tell me. All right. All right, no matter which 2 numbers you chose to break down 24, you should end up with 3 2s and 1 3, right? No matter what you chose. And these multiply together to give you 24. My index is 3. So I'm looking for groups of 3 numbers that are the same. Here's 3 numbers that are the same. Okay. That one of those numbers is going to come out front. The 3 that's left is going to stay under the root, and it's a cubed root. What if I had one more 2 left over here? I know that I don't, but what if I did? An extra 2. What would happen to him? He's going to also go under. So I would have 3 times 2, it would be 6 under here. Okay, if you had an extra 2. All right, now I'm going to do the x to the 6th. So 6 divided by 3 is 2. That comes out. And there's nobody left over under there. So this is my answer. Okay. Everybody okay with that? Remember to practice those. So if you get a decimal in your calculator, it's factor tree time. Pull 1 out from each group that you circle. Everybody else that's left gets multiplied together and goes under that radical. Okay. All right. Last page of this one. You guys are going to be little experts. Now, most of these problems, I didn't make them up. They came right out of my math lab. So as you're doing your homework, have this packet with you because chances are you already have the answer to a lot of the homeworks, right? Or they're really, really close. Okay, so we want to simplify 2 root of 20. Well, this is new. We have never had a number out front before. So we've got to figure out what we're going to do with it. Well, first of all, let's go ahead and take the square root of 20. If you put that in your calculator, you're going to get a decimal. So it's not perfect. That means it's factor tree time. You can do 4 and 5. You can do 10 and 2, right? Whatever you want to do. But when all is said and done, you're going to come up with this. Multiply them together to make sure you come back to 20. Our index isn't there, so we know it's a 2. So I'm going to circle groups of 2 numbers that are the same. He's going to come outside, just 1, and the 5 is going to be left underneath. Now I can't circle that and move on like I normally would, because look who's hanging around out here, a whole nother number. What am I going to do with this number and this number? Multiply them together. This number is being multiplied by the root of 20. So I'm going to multiply them together. 2 times 2 is 4, and there's my root of 5. Okay? So you're multiplying. This is one of those unfortunate situations where, you know, even if you had added them, you would have got the same answer. I hate coincidences, but you want to multiply. This was a 3 out here. 3 times 2, this would be a 6. Okay, you want to multiply. All right, here we go again. Well, we're already separated. Now, before you hop right in, let me show you something, okay? A lot of times, if they have already separated them for you like this, there's a chance that if you go backwards, it will make it so much easier to go forwards, okay? So just watch for 1 second. Let me show you something. Well, let me show you 2 different ways to do this. All right, so if I just leave it the way that it is, okay, if I leave it the way that it is and I keep going, my index is 2. So for x, I'm going to have exponent of 7 divided by an index of 2. Okay, it's going to go in 3 times with a remainder of 1, right? So I'm going to have x to the 3 outside with an x to the 1 under, right? Now we'll do the y's. I'm going to have exponent of 5, divided by index of 2. It goes in twice, remainder of 1. That means I'm going to have y squared outside, 1y under. Okay? Remember, this whole number is who comes outside. The remainder is who stays under. Then, if I compare that to my denominator, what can I do? I can cancel. And your whole answer is just x cubed y squared. Okay? Now, what I was going to show you is a lot of times if they do this and they separate it like that, what you can actually do is create one giant square root. It's kind of going backwards. Okay? And then you can clean up what's under here. So this is just another way you could do it. So 7 minus 1 is x to the 6. 5 minus 1 is y to the 4th. Then if I take the square root, 6 divided by 2 is x cubed. 4 divided by 2 is y squared. I get the same thing. So whichever way you think is easier, but whenever you see anything like that, like look down here, right here, these two, whenever you see a square root in the top and a square root in the bottom, especially in this class, chances are you can write it under one giant radical and do a lot of reducing to make your life easier, okay? All right, let's try this next guy. He does not have a fraction, so he's just a 4th root. So we're practicing who goes in, who comes out. So here we go, in. He has exponent of 9. I'm going to divide by the index of 4. 4 goes in there twice with a remainder of 1. Okay, this is who comes out. This is who stays in. So n squared comes out with a 4th root of n that stays in. Okay, now I'm going to do m. (12) divided by 4 Well, that's just a nice little 3. I don't have any remainder. So the whole m cubed comes out. And that's my final answer. Okay, 12 divided by 4 is 3. I don't have any leftovers. Only leftovers stay under the radical. That's it. If you don't have any leftovers, nobody stays under. Okay, everybody all right with that? Let's look at this next one. I can't simplify the square root of 14, and I can't simplify the square root of 2. And we don't know how to divide radicals yet, because so far every division of a radical we've done, I don't know if you've noticed, has magically come out where there's no radical sign in the denominator. That's for a reason, because we haven't got there yet. We're getting there. So far we don't know what to do. But one of the unwritten rules of math, the giant no-no that the math people will come and, you know, spank you for, is if you leave a radical in a denominator. So what's another option that I could do for this guy? I could put the whole thing under 1. And if I do that, it reduces down beautifully to the root of 7. And then I'm reduced. So try not to ever have a radical in a denominator. There's always a way to simplify that down. Okay. All right, last one. This would be sort of a bonus situation because it's very hard. This would not be a test question, but just take it step by step and we're going to follow the rules and it'll come out. Okay. So what I notice is that each of these has the same index so that I can go on and do stuff. Now, you can leave them separate like we did up here, or you can put them under one giant radical and fix it first. I just kind of like the giant radical situation, so that's where I'm going to go with this, and then I'll clean it up at the end. You can do it either way. All right, so I'm going to write my top over exactly the way I see it. Now in the bottom though, I'm going to go ahead and make one little correction. Look at this y to the -4. He can't stay down there anyway. Where does he need to go? Yeah, stick him up top. Okay, so that's what we're looking at. Let's clean this up first. That doesn't look so bad. Okay, so if I put in my calculator 81 divided by 3, I get 27. Okay, what am I going to do with these exponents? 10 and 5. Subtract. I know which one's bigger in this case. 10. 10 minus 5 is 5. He's going to stay in the top. What am I going to do with these y exponents? Add them. 2 plus 4 is a nice 6. I don't even have a denominator anymore. Look at that. Okay. So now all I have to do is take the root. So if you're not sure about 27, put them in your calculator. He does have a nice little cubed root. It's 3. 3 times 3 times 3 is 27. Okay, now let's look at these x's. If I take his exponent and I divide by his index, 3 goes into 5 one time with a remainder of 2. So x to the 1 is going to come out. X to the 2 is going to stay under. Okay, now let's do my y's. 6 divided by 3, that's a nice little 2. He's going to come out completely, and I don't have any y's under. And there's your answer. Okay. Oh, did I get too low? I swear, this class, I could be over here on, like, there could be someone behind me with a giant knife ready to kill me, and you guys would be like, so just, you know, throw me a bone here. Help me out. Okay. Everyone okay on that? Good? All right. Well, even if you're not, I would expect the same expression. So I'm going to get you talking one day. At least Teresa says so. Okay. All right. So homework 4. Here we go. So you now, I'm feeling a little better about you. I'm feeling a little more confident. I don't know if you are, but I'm feeling a little better with you. So now what we're going to start doing is adding, subtracting, and multiplying. I told you we don't actually divide. We just simplify. So that's why there's no division. But that's what this is up here. Okay, so here's the deal. All right, if you are going to, we're going to add and subtract first. So these rules apply to add and subtract. We had said before that multiplication and division, they only need one thing in common, same index, right? If you have the same index, go for it. But we know that addition and subtraction are the problem children. We know they're always more difficult. So not only do you have to have the same index, because that's what you have to have for multiplication and division. Look what else you have to have for addition and subtraction. The same radicand. Good grief. Do you know how specific that is? You have to have the same stuff under the radical and the same index outside the radical, or you can't do anything. That is a whole lot of similar stuff together, right? Okay, so let's talk about this. This is everyone's favorite little game show here. Is it like terms? Is it not like terms, right? We're gonna figure it out. What can we combine? What can't we combine? Okay, so over here, 3x plus 2x, are those like terms? Yeah, there's not even radicals there, but we can combine them because they have the same letter with the same exponent. So 3x plus 2x is a nice little 5x. My pencil's giving out. Okay. All right, look over here. 3 root of x plus 2 root of x. These are also like terms because let's look at what they have in common. They have the same radicand, which is an x. They have the same index, which I don't even see, but I know it's going to be a 2. Now, they don't have the same coefficient, but that's okay. That's not a requirement. As long as it's the same inside and the same index outside, you're fine. So 3 square root of x plus 2 square root of x is going to be 5 square root of x. Notice what did not change. This whole part did not change at all. It's kind of like right here where we had 3x plus 2x equals 5x. We didn't make it 2x's. We didn't make it x squared. We didn't change that variable at all. We're not going to change this at all either. Okay, it's the same situation. The only time this changes is if you're multiplying. That's it. Okay, now we know 3y plus 2x, those are not like terms, right? There is nothing you can do, so they're done. Okay, same way with this. Why can't I combine these? What's the problem here? Yeah, little index, right? That index. He has an index of 2. He has an index of 3. I can't combine them, even though they have the same stuff under. So if I had to write this as my answer, I would have to just write the whole thing over. That would be my answer. That's as simplified as I can be. Okay? So that's kind of your little crash course in this. That's basically the whole addition and subtraction situation. So now we're going to do some examples. Okay. So here's the deal. Even if your radicands don't appear to be the same, most of the time you can kind of work a little math magic and make them the same. Not always, but a lot of times you can. If the index isn't the same, forget it. Move on, right? But if your index is the same, usually you can work with it a little. So try to reduce them and see what you can do. All right, so here I have square root of 27 plus the square root of 75. Ugh, well, definitely not the same radicand, so I can't add them together yet. But look, they do have the same index. So let's reduce each one of them and see what I can come up with. So if I put square root of 27 in my calculator, I'm going to get a decimal. It's not going to work, right? So I'm going to break it down. I'm going to have to do a factor tree. And this is what I end up with. My index is 2. So I'm going to circle a group of 2 of the same. I'm going to bring that out, just one of them out, and leave everything that's inside there. Okay. So I reduced root of 27 to 3 root of 3. All right, square root of 75 is a decimal. Okay, factor tree them down. What would 75 be? Well, I'm going to do 25 and 3. Okay. Break them on down. All right. I need groups of numbers, two numbers that are the same. These two 5s are the same. I'm going to pull one of them out, and I have 3 left under. Look at there. Can I combine 3 root of 3 and 5 root of 3? Sure, because now I have the same radicand. So what is 3 root of 3 plus 5 root of 3 going to give me? 8 root of 3. Remember, your index doesn't change, your radicand doesn't change. There you go. Perfect. Okay, let's try this one. We're going to subtract. Okay, I can't subtract those because different radicands, but they have the same index, so it's worth a try. If I put 50 in my calculator, I do not get a whole number. So you can do 5 and 10. You can do 25 and 2, whatever your little heart desires. But break it on down. You should end up with a 2 and 2 5s, no matter how you do it. Okay, I need groups of 2 numbers, so I have a group of 2 5s. I'm going to pull out 1 5 and leave a 2 under. Okay. All right, I can't take the square root of 98 either. That's a decimal, so off I go. Okay, I would just put that in my calculator, see if I could divide it by 2. Turns out I can, and I get 2 of 49. All right, easy enough. I can break them down. There we go. I need groups of 2 numbers that are the same. I see a group of 7s. I'm going to pull out 1 7 and leave the 2 underneath. Has a subtraction sign in between, so there we go. All right, again, students get weird. They see that radical and they freeze and forget all their basic math skills. So I get a lot of emails about this. What do I do? What's 5 minus 7? It's negative 2. Throw your root of 2 on the back. You're allowed to have a negative one, okay? I'm trying to just do weird stuff so you guys will get more confident when you do your My Math Lab. Okay, so 5 root of 2 minus 7 root of 2 is negative 2 root of 2. All right, look at all this stuff down here. We got all kinds of stuff happening. Let's get a little crazy. Okay, so I notice my index is the same for both. So I'm going to see what I can come up with. I got a 4 multiplied out here, so I don't want to forget him. All right, so square root of 3. Can I do anything with that? No, so he's going to have to stay under, okay? So here's what I'm going to do. I know I have a 4 hanging around out front. I know I have a square root of 3 that's going to stay under, right? Now I need to do something with those x's, right? So here we go. I'm going to come over here and, oh, yeah, sorry, I got that wrong thing. So I have an exponent of 3, an index of 2, right? 2 goes into 3 once with a remainder of 1. So I'm going to have 1x outside and 1x underneath. And that's what I reduced that one to. Does that make sense? Everybody see where the 4 came from? He was just hanging around up front. Okay, let's try this one over here. I know I'm going to have a 9x out front, right? Okay, square root of 27. Well, I can't do that, but look up here. If you go back up to the top, we already found the square root of 27. It was 3 root of 3 from up top. So I'm just going to copy that over, okay? That's going to get a little complicated. So notice that there's a 3 outside, right? I'm just going to kind of put a 3 there in parentheses, and I'm going to put this 3 underneath. Is that okay with everybody that I did that? Because I'm going to end up multiplying these together and getting 9 times 3. Okay, so I just stuck the 3 there. All right, and then there's an x under there. Can I do anything with that x? No, so he's going to stay under also. All right, if I clean these up, I have 4x square root of 3x plus 27x square root of 3x. Make sure you're okay with that 9 out there. Remember, I just multiplied it by the 3. The 3 came from the square root of 27. Okay, so again, don't worry about that square root of 3x. That's going to be in your answer no matter what. All you're adding is 4x plus 27x. And what do you get? 31x. And there you go. Okay, and there's your answer. 31x square root of 3x. Okay, let's see what I can do down here. Look at this last one. Well, here's what I notice. All the radicands are the same, 7, 7, 7. I also know 7's prime, so I don't have to do any kind of factor tree or reducing. Now, can I just add and subtract all of these together? Who's the problem? This is an index of 3. Look at his index. Does he have anyone else to combine with? No. So he's just going to come on down into your answer the way he is. He's reduced, but there's nothing you can do with him. Can I combine these back to? Yeah, they have the same radicand and the same index. So 4 root of 7 minus 6 root of 7 is going to be negative 2 root of 7. And that's your answer. So you're going to have a lot of answers that may look upon first glance like you can combine them, but just remember the index rule, index and radicand rule, okay? All right. We've got these last 4, and then we get into multiplication and, well, not division, I almost said that. We get into multiplication. Okay, so let's see if we can get these in. We'll see how fast we can go. All right, so I notice these both have an index of 2. So there's a chance these could combine and work nicely, right? Okay, so here we go. I've got an 8 out front. This is square root of 5. Can I do anything with that? No, so he's going to stay under. All right, what about x though? He's got an exponent of 3 and an index of 2. He's going to, 2 can go into 3 one time with 1 left over. So I'm going to have 1x on the outside and 1x on the inside. Okay. Here we go with the next one. I've got a 4x on the outside, so I'm just going to write it over. Okay. I have a 20 under here. Well, square root of 20 is not going to work, but I can reduce him. You can do 4 and 5. You can do 2 and 10. You're going to get a nice little group of 2 right there. Okay. Pull that out. I'm just going to put it in parentheses right there because I'm going to have to multiply him by that 4. And the 5 is going to stay underneath. Now, what about this x right here? What's going to happen to him? He's got to stay, right? Because he has an index, an exponent of 1, which is smaller than my index. So my x is going to have to stay under. Okay, clean this up a little bit. Multiply that 2 and 4 together. Now I can combine. Okay, so we know there's going to be a square root of 5x in your answer. So all you're adding is 8x plus 8x, which is 16x. And you get 16x square root of 5x. Okay. That look all right? Okay. All right, let's try this cubed root down here. Good gracious. Okay, cubed root of 56. Well, you can put them in your calculator and try it. Unfortunately, he's a decimal. So here comes the factor tree. I know 7 and 8 give me 56. 7 can come on down. 8 goes to 2 and 4. All right, when all is said and done, you should have 1 7 and 3 2s. Now it's a cubed root, so your index is 3. You want groups of 3 numbers. So I'm going to circle this group of 3 2s. He's going to come out. The 7 has to be left behind. He's a leftover. What about the x under here? He's got to stay, right? Because his exponent is 1 and that's smaller than my index. Okay, we're going to subtract. All right, you can try the cubed root of 189. Unfortunately, that's also a decimal. So I divided by 2, I still got a decimal. I divided by 3 though, and I got 63. So that's 2 numbers to use. Okay, 63 is, whoops, 7 and 9. All right, when you're all finished, you should have 1 7 and 3 3s. It's a cubed root, so I'm looking for groups of 3s. So here we go. There's a group of 3 numbers. I'm going to pull that 3 out, and I'm going to leave the 7 under. What about this x? He stays, right? Because his exponent is smaller than the index. Is everybody okay getting to this point? Okay. All right. So we know our answer is going to have the cubed root of 7x in it. We know that. What's 2 minus 3? -1. Now, if you put -1 out front for me, that's perfectly fine. My math lab may give you some issues. So what's something else we could put besides -1 out there? Just a negative, right? You could just put a negative. Just in case they freak out. You know, they're real sensitive. Okay, let's try this next one then. This next one's going to go faster because it's some pretty nice numbers. So I happen to notice they're all square roots. So we have a chance to combine all of them, which would be fantastic, right? If possible. Now, here we go. We got an a squared out in front of this, so we can't forget him. What's the square root of 16? 4, so that gets to come out. Okay. What about this a? Is he going to come out or stay inside? He's got to stay inside because he has an exponent of 1. Which is smaller than your index of 2. All right, now for your b's, you have b to the 7. So 7 divided by 2, 2 goes into 7 3 times, with 1 left over. So I'm going to have a b cubed, we're on the outside, right? And a b to the 1 inside. I'm just going to have ab inside. Is that okay with everybody? The b cubed came out, the b to the 1 stayed in. Now this is written so strange. It's really good math manners, you know, to write the 4 in the front. But the way that we had taken it one step at a time, it came out kind of funny. Everybody okay with that? Okay. All right, now we have a minus. Okay. So square root of 36 is 6. All right, a to the 5th. So 5 divided by 2, it'll go in twice, exponent of 1. That means we're going to have a squared outside, a inside. Everybody okay with that? And then I have another b to the 7th. Well, we already handled b to the 7th. Remember what b to the 7th was over here? B to the 7th ended up being b cubed square root of b. So I'm going to put b cubed on the outside and b underneath with my a. Okay. So I just handled b to the 7th the way that we did it over here. Okay. And then, oh, hold on. You know it's con day. You got time. Just a second. We'll finish this one and be done. We won't do the last one. Okay. Square root of 25 is 5, right? And then we already know how to handle a to the 5th, b to the 7th, right? Because we did it over here. So I'm just going to copy what we did here with the a's and the b's. Here's your a to the 5th. Here's your b to the 7th. Okay. So I'm going to get a squared, b cubed with an ab under it. Okay. I know I'm kind of rushing this, but is everybody okay with that? They're all kind of all the same. All right. So can I combine all 3 of these together? Yeah, because look at my radicals. So they're all going to have, your answer is going to have square root of ab in it. Now you're going to have 4 a squared b cubed minus 6 a squared b cubed. What does that give you? -2 a squared b cubed plus 5 a squared b cubed. And you're going to end up with 3 a squared b cubed square root of ab. Okay. And we'll stop there. If you need to, break that up a little more. We kind of skipped a lot of steps in there to try to get it in time. So if you need to, you know, go back and take that one step by step, okay, so that you have it. but that'll get us in a good place for Monday. And I will see you Monday. Bye, I'll see you later.